So we discussed that one of the factors, the first factor uh, that affects the discharge of the ions at the electrode is the position of the ion in the electrochemical series. And we learned that we have different electrochemical series for cations, and we have different electrochemical series for anions. Uh, so this is the electrochemical series, and you can see that the more reactive metals are at the top. Okay, the more reactive anions, the more reactive ions in general are at the top of the series, and as you move down, the reactivity of these ions decreases. So yeah, so the less the ion is reactive, the easier it is to discharge. Okay, so ions at the bottom, okay, will be discharged more easily as compared to ions at the top. So yeah, so because the ions at the top require large amounts of energy to be discharged, and down the table they become easier to discharge. So in short, if you have if you had, for example, if you had, let's say, if you had lead ions and if you had calcium ions in the same solution. So, Rafi, this is a question from you. If you had lead ions and calcium ions in the same solution, which one of these two will be preferentially discharged at the cathode?
कैल्शियम और लेड।
हाँ, so कैल्शियम और लेड में से कौन सा डिस्चार्ज होगा?
कैल्शियम। नहीं,
नो.
कैल्शियम ज्यादा रिएक्टिव है, तो लेड होगा।
Yes, good, very good. Because lead is, it is below calcium, right? So it is easily discharged. Okay, same goes for the anions. Okay, if you have for example hydroxide ion, see, if you had a hydroxide ion, and if you had, let's say, if you had chloride ions in the same solution, so preferentially hydroxide ions will get discharged. Okay, according to the rule of the electrochemical series and the reactivity series. So that's the first criteria. This is also another example of the reactivity series. So you need to remember this for your exams, and I'll share a mnemonic on the group as well. The second factor that is very important in determining the preferential discharge is the concentration of the aqueous solution. So yeah, so the concentration of a solution has an impact on which ions are preferentially discharged. Now listen to this really carefully. This is also a very important factor, and you'll know why. So the concentration of the solution has an impact on which ions are preferentially discharged, because there is a tendency to promote a discharge of the most concentrated ion present. So yeah, this rule of concentration really only applies when comparing anions, especially in solutions containing halide ions, and does not usually apply to cations. Okay? But that's not always the case. So you'll learn in the example we will discuss later in this video of the comparison of the products which are formed at the anode when we electrolyze a concentrated solution of sodium chloride versus when we electrolyze a dilute solution of sodium chloride. This is the second important factor of the which determines the discharge, that which of the two ions will get discharged. So the greater the concentration of the ion, okay, so that's the directly proportional. The greater the concentration of the ion, right, the greater the ease of discharge. Okay, so this is directly proportional. I hope you understand what is directly proportional. सही है. And इधर जो है, the greater the reactivity, सही है, ये inverse proportion है. The greater the reactivity of the metal or the non-metal ion, the lower the discharge, uh, the lower the discharge rate, okay, or the discharge uh, feasibility. So yeah, the third uh, the third criteria which is important for determining which of the ions will get discharged, and this is not really important at your level, is the nature of electrodes. Okay, so whether you're using an active electrode or you're using an inert electrode. Now, what is the difference between active and inert? So any idea, Aslan, what is the difference between inert and active? Like, what is the literal meaning of active and inert? What is inert? Just tell us.
Reactive, if it's reactive or not.
Yeah, सही, exactly. So an active electrode जो है will be made up of uh, uh, will be made up of substances which are reactive. ठीक है? And inert electrodes, they will be made up of conducting substances, obviously, which are not reactive. So, for example, if you have carbon electrodes, okay, if you have carbon electrodes, or we have, for example, a form of carbon electrodes like graphite, okay, which is a very good conductor of electricity. If you have graphite electrodes, okay, they're a very good example of inert electrodes, okay? Versus if you have active electrodes, they will react, okay? So for example, if you have copper electrodes, right? So copper electrodes will react, will also take part in the reaction. And you'll see how. The type of electrodes chosen for electrolysis also affects the reactions occurring at the electrode, especially at the anode. Inert and active electrodes can be distinguished by the fact that inert electrodes do not take part. Okay? They will never take part in the reaction, whereas active electrodes will do. So yeah, as I stated earlier. An example of an active electrode is copper. Okay? This is the example I gave you. Whereas graphite, platinum are examples of inert electrons. Now you will argue that platinum is a metal, okay, it should react, but platinum is way down in the reactivity series as well, okay. So see, if you look at this reactivity series, platinum is like way down there. You can even use gold electrode, but gold is so valuable and so expensive that we prefer not to use it. Gold is because of the low reactivity of gold and platinum, by the way. They are also used in mobile phones, and इसके अलावा जो भी इस तरह के semiconducting circuits होते हैं ना उसमें use होते हैं because they do not react with they do not undergo the atmospheric changes that easily. They do not oxidize and react with water. Okay, so that's all for the factors which are affecting the preferential discharge of the ions. And there are three factors. So just to sum up, the first factor is the position of the ion in the electrochemical series. That's the first factor. Okay. Then we have the concentration of the aqueous solution. That's the second factor. And the third factor is the nature of electrodes. So if you're using active electrodes, there will be a different product. And if you're using inert electrodes, there will be a different product. So because active electrodes take part in the electrolytic reaction versus the inert electrodes like graphite and silver, they do not take part in the reaction. So yeah, and the only ions that are taking part in the reaction are the ions in the electrolyte. So yeah, that sums up our lesson.